Hi friends, welcome you all to Think Maths. We are in class 11 Maths chapter 9 straight lines. So where do we find straight lines? Now look at this. So here there are so many objects. Now you can have a orange line here. This is a divider. So this line is a straight line. It divides the road and you can see a straight line in banana leaf. So this scale it should be a straight line and the rope it is straightened. Okay. So and look at this umbrella. So this umbrella handle it should be straight. So you can find straight lines in so many practical things. Also, let us see where do we find other straight lines. Now, have a look at this. So this machine moves in a straight line. It has a belt. This belt is constructed in such a way it is straight. So this machine moves in a straight line. So you can find straight lines here. And then you can see so other straight lines in other things also. So now look at this. So it has this road has a divider. So it is done in a straight line. And you can see this lands is divided using straight line. So you can find straight lines here and this line is a straight line and the car moves in a straight line. So you can find so many things using straight line. Now look at this. So you have a building. See, this is the building they are constructing. Okay, so when they are constructing a pillar you need to place these rods in a straight line, so the pillar is erected straightly. Okay, and you can find straight lines here. Now look here, there are so many straight lines arranged. Okay, these rods are in a straight line, so you can find straight lines in so many practical problems. So now we have to learn how to measure the distance in a straight line, and then you have to know about the slope intercept form and areas. Those things will be learnt in this chapter 9. So let us get into the chapter. So now, what is a straight line? Okay, so it is nothing but shortest distance between 2 points, because see here now we have 2 points. These 2 points. So here it is a school and this is a home. How to travel from school to home or home to school? So you can travel in this way, and you can travel in this way also. Okay, looking funny? Yeah. So also now you can travel in this straight line also. And if you measure this, this straight line will be the shortest distance between home and school. So that's why straight line is called the shortest distance between 2 points. Okay. Already in 10th standard in coordinate geometry, in the chapter coordinate geometry, we have learnt about distance between 2 points. Those things we have learned. So those things will be revised now. Now at first we have distance formula. So what is the distance between these 2 points A and B? Okay. So if you find out the distance, it is nothing but if these 2 points are x1 comma y1 and B is x2 comma y2, then the distance between them is under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is the distance between 2 points A and B. So if this is the point A and if this is the point B, so the distance between A and B can be found out using this formula. Also you should know to plot the points in a graph. So this is the positive x and this is negative x. So this is 1, 2, 3, 4 and this is minus 1, minus 2, minus 3, minus 4. And this is positive y. So it is 1, 2, 3, 4 and this is negative minus 1, minus 2, minus 3, minus 4. So where is this point P? So it goes straight to 3 in x and straight to 3 in y. So it is 3 comma 3. What about A? The point A is in x-axis, it is minus 3. In y-axis, it is minus 4. Okay, so these are the coordinates of A and B. Okay, now we can find out the distance between A and B. So AB is nothing but square root of x2 minus x1. So what is A? A is minus 3 minus 4 and B is 3 comma 3. So this is x1 y1 and this is x2 y2. So here no need to get confused whether x2 should come or x1 should come here. You can write even x1 minus x2 whole square plus y1 minus y2 whole square, because as it has the power 2, whether you get negative or positive, it will turn into positive. So just you have to find out the difference of x coordinate square plus difference of y coordinate square. Okay. Now the difference of x coordinate. So it is minus 3 and 3. So if I take here minus 3 whole square plus y coordinate difference minus 4 and 3. So minus 4 and this is plus 3. Minus 3 is negative. Correct. So minus 3 square, minus 4, minus 3 square. Yes. So square root of minus 3 is minus 6. Minus 6 square is 36 plus minus 4 minus 3 is minus 7. 7 minus 7 whole square is 49. So it is nothing but square root of 85. So this is the distance between A and B. Okay, clear? Now suppose if one point is in the origin. Okay, so if one point, so this is the origin, that is you can have it as playground. Okay, so if it is the playground or park, what will be the distance between playground and home? Okay, or park and the home. So it can be just say a square root of x square plus y square, because as the origin will be at 0 comma 0. So it is 3 minus 0 whole square plus 3 minus 0 whole square. That's why we will write it as x square plus y square. So if the home is at 3 comma 3, so 3 minus 0, so it is 3 square plus 3 square. So which is 9 plus 9. So 9 plus 9 is 18. This can be written as square root of 2 into 9, as 9 is a perfect square. So it is 3. Root of 9 is 3. So it is 3 root 2. Okay. So this is the way you have to find distance between 2 points. So this we learnt already in class 10. So you were all familiar with this. So shall we move on to the next one? Yes. So the next one is, so there are 2 points A and B. This point is divided by another point C in the ratio m is to n. Okay. So if it is so, we have learnt a section formula. What is that? This point can be found out using this section formula. C of x comma y is equal to m into x2 plus n into x1 divided by m plus n. M into y2 plus n into y1 divided by m plus n. So this is the way we have to find out the value of x and y. That is, where does C exist? Where does the point C exist? This is the section formula. It is easy to remember. So m is here, go to the opposite. It is x2. mx2 and n is here, go to the opposite, nx1. So first part is x coordinate. In the same way, second part is y coordinate. So m, go to the opposite y coordinate, it is y2 plus n into, go to the opposite y coordinate, y divided by, you have to add the ratios m plus n. So this is the section formula. In this section formula, it is a special case. That is, there is a straight line AB, okay, and there is a point in P which divides AB in the ratio 1 is to 1. That is, this point P is called the midpoint. If the ratios are same, then that point is called the midpoint. So if this is 1 is to 1, 2 is to 2 means you can divide by 2 and write it as 1 is to 1. So at last, if the simplified ratio is 1 is to 1, then the point is called the midpoint. So if it is so, if you substitute 1 here, it is x2 plus x1 divided by 1 plus 1, 2. So it is x1 plus x2 by 2, comma y2 plus y1 by 2. That is the midpoint formula. To find out the midpoint, you can add the x coordinates and divide by 2. Add the y coordinates, divide by 2. And you will find out the midpoint P. Okay. So this is the simplified form from section formula. Clear? So these are the things we learned in coordinate geometry in class 10. Okay. Now slowly we will move on to class 11. In class 11 we are going to learn area of triangle. Okay. So this is the triangle. In triangle you have three vertices. A x1 y1, B x2 y2, C x3 y3. So what is area of triangle? So it is nothing but 1 by 2 into x1 into y2 minus y3. So the point x1 is here. Now let me draw the direction. Okay, if it is so, take this point x1. Who is opposite? Here, this line. BC is the line opposite. Just you can remember easily. 1 by 2 into x1. If you take x1, its opposite line is BC. What is in the order? y2, y3. In this order. So y2 minus y3 plus x2. So who is opposite? This AC line is opposite. The order is, the direction is here. So in this way it goes. So it is y3 minus y1 plus next x3. Okay. So its opposite line is AB. It goes in this way. So it is y1 minus y2. So this is the area of the triangle. So if three vertices are given, you can find the area of the triangle using this formula. Okay. So before that we found it is half into base into height. So if you know that base and height, we use this formula to find area of triangle. Now if we know the vertices, okay, if you know the vertices, you can use this formula to find area of triangle. In this special case, that is, if the area of the triangle is 0, so that is there is no area here. So this is the area occupied by a triangle. If there is no area, that means this point A, B and C will be in a straight line. Okay. All these points will be in a straight line. Okay. So now if you take base BC and you have A here. If the area is 0, this A will lie in the line BC. So there will not be any area. So if you want to prove that three points are collinear, you can use the area of the triangle formula. So if A, B, C are collinear, then area of the triangle ABC will be 0. If it is 0, we can say A, B, C are collinear. Okay, clear? So if the area of the triangle is 0, it is collinear. Or if the points are collinear, then we can say area of the triangle is 0. Okay. So both are if and only if. Converse is also true. Clear? Shall we move on to the next one? Yes. So now we are moving to the topic slope of a line. So that is how a line is inclined. Okay. So this is the inclination. How this line is inclined to x-axis. So now we have x-axis and y-axis. This is the line. This line is inclined to x-axis with the angle theta. Okay. So as this is a straight line, the remaining angle will be 180 minus theta, and you have 2 points A and B in this line here. If these data are given, we can find the slope of a line. The slope of a line is nothing but tan theta. Okay. Slope of a line is tan theta. Now suppose if the slope of a line whose inclination is 90°, then it is not defined. That is, if this slope has the inclination 90°, that is, it will coincide with y-axis. Okay, but tan 90 is not defined. What is tan 90? Sin 90 by cos 90. Okay, so sin 90 is 1, cos 90 is 0. This is not defined. So, if this is line coincide with y-axis, then the slope is not defined. Okay, so or you can say if theta is equal to 90°, slope is not defined. Usually, we will denote the slope of a line by the letter m. Okay, so m is equal to tan theta with the condition theta not equal to 90°. Also, if you take the axis, slope of x-axis, so there will not be any inclination. It will coincide with this line. So, slope of the x-axis will be 0 as theta will be 0 and slope of y-axis is not different. So, these are the properties for a slope of a line. Next, we have 2 points A and B. So, if these 2 points are given, we can also find out the slope. It is just y2 minus y1 divided by x2 minus x1. So, this is the slope of the formula. If theta is given, tan theta will give the answer for slope. If the points are given, if 2 points are given, then you can find out y2 minus y1 divided by x2 minus x1. So this will give the slope of a line. Clear, children? So moving on to the next topic, slope of parallel lines. Okay. So now if you look here, these two lines are parallel. If these two lines are parallel, what do you know about this inclination, alpha and beta? What will be its value? Can you say? Yes, I think you guessed it. Yes, these values will be equal. As they are parallel, their inclination should be equal. That is the, because this line x-axis is the transverse of this line. Now we know that corresponding angles are equal. This alpha and beta are called the corresponding angles, which you have learned in the 6th, 7th classes. Okay, so corresponding angles will be equal. So we can say alpha is equal to beta. If alpha is equal to beta, tan alpha will also be equal to tan beta. So if we assume the slope of this line is m1 and slope of line L2 is equal to m2, then we can say m1 equal to m2. Okay, so that is the slope of parallel lines. So if the line L1 is parallel to L2, then their inclinations, that is alpha and beta, are equal. So therefore, slope of line L1, because tan alpha is equal to tan beta, which is the slope. So both their slopes will be equal. So we can come to the conclusion that two non-vertical lines. Why we use the word non-vertical? Because if it is vertical, then it will have the angle as 90°. That's why we use the word two non-vertical lines L1 and L2 are parallel if and only if their slopes are equal. So what do you mean by this if and only if? That means its converse is also same. That is, it converse is true. That is, if this is so, if the slopes are equal, then we can say the two lines are parallel. Or you can say if two lines are parallel, then their slopes are equal. Okay. So that is converse is also true. So only we use if and only if. Okay. Next one, slope of perpendicular lines. Now, perpendicular lines means we have two lines L1 and L2. These two lines are perpendicular. Okay, it is not perpendicular to x-axis. The lines L1 and L2 are perpendicular and it has an inclination alpha and beta. So, L1 has the inclination beta and L2 has the inclination alpha. If it is so, what is the condition for their slopes? That is, if you multiply their slopes, it will be minus 1. That is m1 into m2. Tan alpha into tan beta will be minus 1. Or you can say m2 is equal to minus 1 by m1. That is, one slope will be negative inverse of another slope. How these alpha and beta value will differ means one angle will be increased by 90 degree with the other angle. So beta will be equal to alpha plus 90 or alpha will be equal to beta plus 90. So these are the properties in a perpendicular lines. Okay. Now we can come to the conclusion that two non-vertical lines are perpendicular to each other. Okay. So these are not perpendicular to x-axis. So they are perpendicular to each other. L1 is perpendicular to L2. Two non-vertical lines are perpendicular to each other if and only if their slopes are negative reciprocals of each other. That's what it is said. One slope will be equal to negative reciprocal. Reciprocal means 1 by. So reciprocal of each other. Or you can have m1 equal to minus 1 by m2. Or you can have, if you cross multiply, m1 into m2 will be equal to minus 1. If this condition is satisfied, we can say those two lines are perpendicular, or if these two lines are perpendicular and we have to get m1 m2 is equal to minus 1. So both the statements are true. That is, the converse is also true. Okay. So if it is parallel, slope should be equal. That is, m1 by m2 is equal to 1. If the slopes are perpendicular, then m1 into m2 is equal to minus 1. Okay, clear? So these are the slope of parallel line and perpendicular line. So let us move on to the next topic. It is angle between two lines. So we have two lines L1 and N2. If we have to find out what angle it forms. What is the angle between two lines? This is the inclination of the line L2 with x-axis. This is the inclination of the line L1 with x-axis. With these angles, we can find out the slope. So, slope of L1. So, slope of L1 will be equal to, so L1 has the angle alpha 1. So, it is tan alpha 1. Slope of L2. So, L2 has the angle alpha 2, which is tan alpha 2. So, using the values of alpha 1 and alpha 2, we can find out the slopes tan alpha 1, which is M1, tan alpha 2, which is M2. So if we find out M1 and M2, then we can easily find out the angle between L1 and L2. So how to find? So it is nothing but L1 and L2 are non-vertical lines with slopes M1 and M2, and these are the inclinations. Alpha 1 and alpha 2 are inclinations. Then we can find out the slope of line L1, slope of line L2 using this formula. If we find out this, then we can find out angle between L1 and L2 using this formula. That is tan theta is equal to modulus of m2 minus m1 divided by 1 plus m1 m2. Okay. So with this, you can find out angle between two lines, theta. Clear? So this formula you have to remember. Then what is collinearity? Already we know that if 3 points lie in a straight line, that is we know AB plus BC should be equal to AC. If this condition holds, then we can say ABC are in a straight line. Then you can say ABC are collinear. Then what about the slope? That is the slope will hold this. That is, slope of AB will be equal to slope of BC. Only then we will have this point A, point B, point C are collinear. So this is the condition for collinearity with the help of slope. Okay, we have slope of AB is equal to slope of BC, then it is collinear. Or another one is if area of triangle ABC equal to 0. This condition also says ABC are collinear. Or if you find out the distance between AB, find out the distance between BC, and if you add, you should get the answer for the distance between AC. And this is another condition for collinearity. So to check the collinearity, you can use the slope method, area of triangle method, and you can use the distance method. So you have three methods to find out whether the 3 points are collinear or not. Okay. So shall we move on to the next topic? So the next topic is point slope form. Okay. That means this point is fixed. It can be 2 comma 3, and this point will vary. Point P varies. One point is fixed and another point varies. Then we can have the equation of the line as y minus y naught equal to m into x minus x naught. So this is the equation of the line passing through the point P of x comma y with the slope m through the fixed point q of x naught comma y naught. So this q is constant and this p varies. If it is so, this is the equation of the line with the slope y minus y naught, and this is the slope. This is the slope of the line, this line, and if you know the slope, you can find out the equation of the line. Suppose both the point varies, P and Q differs, then you can find the equation of the line using 2-point form. So if these 2 points P of x1 comma y1 and Q of x2 comma y2 are given, then the equation of the line is y minus y1 equal to m into x minus x1. From the slope m. What is the slope m? It is nothing but y2 minus y1 divided by x2 minus x1. This we learnt in the first part. Okay. We learned the slope using 2 points. Okay. This is called 2-point form. So this is point slope. If your point is there and a slope is there, then you can find out the equation of the line using this point slope form. If 2 points are given, then you can find the equation of the line using this formula y minus y1 equal to m into x minus x1, where m is y2 minus y1 divided by x2 minus x1. This is 2-point form. Okay. Next one. So next one is slope intercept form. Okay. Suppose the line L intercepts the y-axis at C. So this point P will be 0 comma C. If the point is in y-axis, x coordinate will be 0. So we can have the assume the y coordinate as C. If it is so, then you can find out the equation of the line by y is equal to mx plus c, where m is the slope of the line and c is the point value where the line cuts the y-axis. Okay. So y is equal to mx plus c. So this is the equation of the line for slope intercept form. Next one is intercept form. That is, if the equation cuts the x-axis at A and cuts the y-axis at B, we have both the intercept of x-axis and y-axis. Then we can find the equation of the line using intercept form. Okay, x by A plus y by B equal to 1. Okay, suppose if the slope is not known, if you know the intercept of x-axis and intercept of y-axis, then you can use this equation to find the equation of the line. So if you know the slope and one of the intercept at y-axis, then you can use this equation to find y is equal to mx plus c will give the equation of the line. Clear? So just remember all these formulas. Okay. Next one, last topic of this straight line, distance of a point from a line. So that is a line L. Its equation is given ax plus by plus c is equal to 0. And there is a point P at x1 comma y1. And we have to find out the distance d. So distance of a point from a line. So from this line, there is a point M. We have to find out this distance, MP. We have to find out distance between M and P. Okay, so this is the equation of the line and there is a point P. If you assume the distance as D, then you can find out D is equal to modulus of AX1 plus BY1 plus C divided by under root of A square plus B square. Okay, so you have to substitute the value of X1 and Y1 here, find out the modulus and get the value of A square plus B square, apply root and you will find out the distance. So distance of a point P from the line. So from line have a point, join these points and you can find out the distance. Okay. So last topic is distance between two parallel lines. So these two are parallel lines L1 and L2 and it has the equation y is equal to mx plus c1, y is equal to mx plus c2. As these two lines are parallel, their slopes will be same. So both their slopes will be m. Only this c1 value differs. So y will be equal to mx plus c1 and y will be equal to mx plus c2. So this is the distance. Wherever you take the distance will be same for parallel lines. So if you find the distance between parallel lines, wherever you find it should be same. That is the condition for parallel lines. If it is so, we can find out the distance between two parallel lines. If these two are the equations, then the distance d is nothing but modulus of c1 minus c2 divided by under root of a square plus b square. So this will give you the distance between two parallel lines. Okay, so these are the topics in straight lines. With these formulas, we will be solving all the problems. Just pause the video, note down all the formulas, memorize it, and this topic will be very simple. We can easily finish the straight line chapter. Okay, once you learn the formulas, this topic will be very easy. Straight line chapter will be easy to handle. Okay, children. Thank you for watching. In the next video, we will discuss the example problems. Thank you.